I just want to explain this one real quick. What you see here is a bunch of diagrams with a seemingly a random amount of stuff, but nothing is random here. Exactly how many molecules you see in there, that's what you want to put in the pictures. So, considering this reaction, the first thing I want you to do is find the value for the equilibrium constant. All right, so that's K here. So we set up the expression. So this is the product, and these are the reactants. And they don't have any exponents because there's no coefficients here. See, everything has a coefficient of 1. So I simply plugged in those numbers, and I got 2 for the equilibrium constant, and we're going to need to use that later. Draw an image to represent the initial state. So what I did there is I drew 4 A's, 8 B's, and sorry, start over again. 1 of these A's, 4 B's, and 8 of AB2. So you see that all here. There's this lone, that's the A, and then we got the ones with the circle and the X's. There's should be 8 of those. Yeah, there's 8 of those, and 4 of just the X's. And then it says at some point you're adding 13 of these. Now, one thing we're going to ignore is the CL because they call it a spectator ion. It doesn't actually affect anything, just kind of there. But so they don't even want you to draw those. We're just going to draw an extra 13 of these. So the second diagram here has 8 of these original ones plus 13 more. So just to write down the numbers that they have there, the A's. I'm gonna leave out the charges. All right. So there is still the 1A, and there's for the B's there is still 4 of those 4 lone X's. Kind of hard to see, but you can count them all up. Here we got 1, 2, 3, 4. And then for the last one, the AB plus 2, we have a total of 21. All right, so that is the 8 original plus another 13 added. So that's how we get the middle picture. Now for the final picture, we have to do a little work to do that. So we're going to fill out an ice table. So with this one, we don't want to do the initial state because that's already in equilibrium. We want to do starting from this diagram right here. So we're actually going to use all those same numbers I just wrote. So that's going to be 1, 4, and 21. Now what's going to happen is since we introduced extra ABs, that's extra product, the direction of the reaction is going to move towards the left. It's going to produce more of these guys. So the way we represent that in the ice chart is by the C. That's the change. So we're going to lose some of these. We're going to gain some of these. Now, sometimes when you make these diagrams, you have coefficients in front of them, but there's no, again, no coefficients in the equation, so just X is there. So then at least with 3 expressions, when we add these up, the equilibrium, we got 1 plus X, 4 plus X, and 21 minus X. So what we're going to do with that is take this K expression, and I'm going to plug in all that. So for AB, we have 21 minus X on top. And on bottom, we have the A's and B's separately. So we got 1 plus X and 1 minus X. So I want to stress that you don't actually have to solve these equations. So you don't want to go simplifying that. It can be done, but it's just a bunch of like quadratic solving and whatnot. So instead, I'm going to set this equal to 2 because that's the equilibrium constant that we want. So basically, going to copy all that down, then we're going to switch to the graph. So you want to pause to do that. So this is from before. That's nothing. All right, so in this here, I'm gonna do 21 minus x for the products and divide that by 1 plus x and sorry, I had to go back and look at the other stuff there. And 4 plus x. And I want to see that where this meets 2, so I'm going to do y equals 2. Don't worry about this like step stuff. So you just look at the graph and you want to see where these intersect. They intersect in 2 points. That's negative. That's probably not what we want. But this right here, this point says 1 comma 2 as an x value of 1. So that is the x value we're trying to solve. Okay, so we didn't actually solve any of that. We did it with the grapher. Right, so we're going to use the x value 1. So I'm going to go back to the other thing. And I'm just going to quickly fill in what we had before. So this was a 1, a 4, 21 plus x because we're going to get more reactants because it's moving to the right. And we had these expressions 1 plus x, 4 plus x, and 21 minus x. Why we need these expressions is because I'm going to plug back in the x that we found and figure out what's going on. So x was 1. So I'm going to do 1 plus 1, 2, 4 plus 1, 5, and 21 minus 1, which is 20. So the ICE chart is essential for figuring out these numbers. So these numbers here is what we're going to use for the final picture. The 2 stands for 2 of the A's, which is this and this. And we got 5 of just plain X's, which is the B's. We got 1, 2, 3, 4, 5 somewhere. There's 5. And then there's 20 left of the this one, the ABs together. All right, so that's how you make those 3 diagrams there. Now for sketching a graph here, normally in the notes, your teacher actually had these as 3 separate graphs, but they're just one here, so I put it all together. It's going up to 21, so I decided to label these by 5s. So I started with this one. This has 1A. That's the 1A over here. And then at some point it goes to this, but it takes a little bit of time. So there's like a little curve there. This point right here, this line, that's where the extra stuff was added. That's where this stuff, the AbCl2 was added. And remember, we're just paying attention to the AB ion because this doesn't affect it. So I labeled each of these what they are. So for the B, we started at 4. That's the 4x's you see in this diagram. And then it jumps up to 5. That's the 5 we solved by using the ICE chart. And a little curve up to show that it takes a little bit of time to get there, but not much. And then this last one here, this starts off at 8, and then 13 was added, so it jumps up to 21. Notice this is like a straight vertical line because it happens like immediately. You just dump it in. But then it reaches equilibrium again and goes from 21 down to 20. So the 20 is this line. It's going down, so I show a little bit of a curve right there. I'm going to stop this and do a separate video for number 2. And for number 2, this one's pretty similar with the diagrams, what we're going to do. Just pay attention to the equilibrium constant expression because that's a little different. It's got an exponent. So here we have the 2 products and 1 reactant here. So the 2 products are on top. Products are always on top. And reactants on the bottom, but we have exponent of 2, which comes from the coefficient of 2 right here. And it says that this is already at equilibrium. So we're gonna just plug in the values. They're 4 for everything. So 4 times 4 over 4 squared, that turns out to be 1. These are, if you notice, like not decimals or anything. They're designed to be that way because we have to do the diagrams. So it says draw the initial state. So here made something with the key, and I just drew 4 of each thing. 4 purples, 4 pink, and 4 yellows. For part C, if at some time all the Z gas is removed and partial pressure Y is reduced, how will the system respond? So if you're going to take away the products, if you're going to take away stuff from the right side, it's going to start moving towards the right side to create more. So I put as my explanation, it will move to the right to reestablish equilibrium. So the middle, this is for part D. Right here, we still have the 4 X's. And there's 3 Y's because of the 3 ATM. It's the 3 purples and no Z's that they took it out. To do the final diagram, we got to do the ice table. No other way. So we're not going to use this initial state because that's already at equilibrium. We're going to use this as the initial state. Because at any point you could choose that to be what the initial state is, but we're interested in what happens from here to here. So we're going to start off with writing those numbers. Well, we have 4 of the pinks, 4 X's, 3 Y's, and the Z was completely removed, so we got 0. I don't like the fact that they use X here because that's going to complicate things, so I might like choose another variable. All right, so what's going to happen is going to move to the right, which means we're going to be losing some of this. Okay, so maybe I'll put like minus, I don't know, P. Instead of X, we don't get confused with this X here. We're going to be gaining, actually not just P, we're going to be losing 2P because of the coefficient. These have a coefficient of 1, so we're going to be gaining one of these, 1P, and I'm going to be gaining 1P here. And then we're going to make the equilibrium expressions. So it's going to be 4 minus 2P. And then 3 plus P, and then just P. So we're going to go back to this expression here and set that up. All right, so the Kp, which is, it turns out to be 1, we have the products on top, so we get 3 plus P. And then P, and then 4 minus 2P, but that's going to be squared. And we're not going to try to solve this, even though we can, because we have the grapher. I'm going to set this equal to 1 because that's the equilibrium constant that we solved in part A. Okay, so take a moment to copy that down, pause if you need, and then I'm going to put this in the grapher. Write that down myself first. Oh, forgot something. It's going to be squared because of the coefficient there. Let me bring the grapher. Okay. So here, I wrote P before. I don't think it's going to like that, so I'm going to put X. This is just the expression that I wrote before. We have that, and I want to know where this meets the line 1 because 1 is the equilibrium that we're trying to find. I should put Y equals 1. Put the line. Again, don't worry about this, all this here. So we got 2 points. We got this one and this one. Only one of these works. So to figure out which one works, you kind of imagine it being plugged into the expression. Now the 4 minus 2x, that's gonna be a problem because you're gonna get a negative number if you plug in the 5.33. Even though you're squaring it, you don't want that. So I'm gonna go with this one, the x coordinate of 1. So this shows us that x turned out to be 1. I think it happened for the last problem as well. Okay, so that's the whole purpose of graphing, is to find the intersection point that makes the most sense. And so I'm gonna go back to the other document. That's this. And quickly copy down some of the stuff we had here. We had 4 of these, 3 and 0, minus 2. I was using p before, and then plus 1 of these, and then plus 1 of these. And our 3 expressions, we had 4 minus 2p, 3 plus p. Again, I'm only using p because we already have an x, and that could be confusing. But from the graph, or from Desmos, we find that p is supposed to be 1. That's what makes it at equilibrium again. So I'm going to plug in 1 into each of these expressions. Right, so for this one, that's going to be 4 minus 2, that's 2. 3 plus 1, and just 1 here. So the ice table is essential for figuring out the diagram. So for the x's, we have 2 of those. That's the pink circle. And we had 4 of the y's, that's the purple square. And 1 of the z's, that's the yellow triangle. And that's it.